Hello there. A hearty welcome to Moody Institute of Science. For several years here at the laboratory, we've been studying the human senses. And the deeper we go into the subject, the more fascinating and wonderful it becomes. As we explore the mysteries of sense perception together, we're going to have a lot of fun. There'll be some surprises and quite a few chuckles. But also, we're going to discover that there is real significance in the study. How many senses are there? Well, more than the traditional 5. A lot more. But it's not without reason that these 5 have been called the windows of the soul. The sense of sight, which opens to us all the beauty and wonder of the world around us. The sense of hearing and the many voices of the world. The sense of taste with its endless delights. Oh yes, and that wonderful sense of smell. The sense of touch with hands both young and old. Viewing the senses individually, we find that they are wonderful indeed. But our senses don't function independently. They operate together as a team, forming a smoothly integrated, complex electronic system. Let's watch this system work at a baseball game. Nice catch. But let's take a closer look at the electronic magic behind that catch. At the instant the ball was hit, countless bits of information were flashed to the outfielder's brain. His eyes told him the angle at which the bat hit the ball and the direction it was starting to travel. His ears told him how squarely and how hard the ball was hit. His sense of touch gave him clues as to wind direction and velocity. And from his memory came thousands of clues gained through past experience. This information was combined to solve a complex problem involving geometry, trigonometry, calculus, and ballistics. And he makes the catch. In a single day of normal activity, it is probable that the sensory system of your body will handle more messages than have been carried by all the telephone and telegraph lines in the whole world during the past 50 years. The human senses are wonderful, and they serve their intended purposes well, but in their ability to perceive the world around us, they are extremely limited. Let's take the sense of sight, for example. Now, our eyes are sensitive to a particular range of frequencies, which we call visible light. But visible light is merely a small part of the electromagnetic spectrum, which includes electric waves, radio waves, infrared, ultraviolet, X-rays, gamma, and cosmic rays. Now, in a very real sense, all of this is light, but nearly all of it is light we cannot see. These frequencies have special meaning for us merely because they are the ones to which our eyes will respond. Now, of course, electric waves and radio waves have different properties because they're different wavelengths. But that same thing is true of any part of the spectrum. Even in the visible spectrum, there are different wavelengths which have different properties. In the electromagnetic spectrum, the longest waves are the electric waves, which commonly supply us with power. Electric waves are some 3,000 miles in length. But as they become shorter and vibrate faster, they gradually merge into radio waves. The longer radio waves we pick up on our standard broadcast receivers. For shorter waves, we have to use shortwave receivers. television sets, various radar systems. But as the waves become shorter and vibrate still faster, we move into the infrared section. These waves cannot be tuned in on our radio or TV sets. Instead, we tune them in on our bodies and call them heat. Wavelengths of invisible infrared light are so close to the longest waves of visible light that often both can be detected at the same time. Moving across the visible spectrum, the waves become shorter and vibrate faster until finally visible violet disappears into invisible ultraviolet, sometimes called black light. Now, ultraviolet rays are too short and vibrate too fast for the human eye to see, but there are ways we can see their effects. Sunburn, for instance, is caused by invisible ultraviolet light. Some minerals can change invisible ultraviolet light into frequencies we can see. Rather ordinary looking, aren't they? Well, now let's shine some invisible ultraviolet light on them. Instantly, they flame into glowing beauty as short waves of invisible ultraviolet light are sent back as longer waves, which we can see. Traveling farther down the spectrum, we come to X-rays. Of course, our eyes are not sensitive to X-ray light, but photographic film is, a fact made use of every day in medical laboratories. So in reality, we who think we see so much are groping around in a world ablaze with glory and wonder and light and color, and we're almost totally blind. Now, does this mean that our sense of sight is any less amazing and wonderful than we had supposed? Not at all. It merely means that the universe around us is infinitely more wonderful than anything of which we've ever dreamed. Now, all of us have heard someone say, "I will not believe in anything that I cannot see with my own two eyes." Well, the very least that you can say about such a person is that he must have a narrow view of the world around him. Yes, our vision certainly is limited. But how about the sense of hearing? Is it also limited? Well, did you ever hear one of these? Quiet, isn't it? No, not really. This is an ultrasonic dog whistle. Actually, the sound is very loud. A dog can hear it all over the neighborhood. But it's beyond the range of the human ear. Now, we've built a super high-powered dog whistle. In the science laboratory, it's called a Galton whistle, after Sir Francis Galton, who invented it. The whistle is now blowing full blast. Though completely inaudible to us, it is of tremendous intensity. In fact, it is so loud that the sound can actually be used to support objects in midair. The silent sound from the whistle is bounced back and forth to form a standing wave pattern. These waves whip the air molecules into a stormy sea of violent motion, except at 2 points in each wave. It's at these points, or nodes, that the cork chips are suspended. This world of silent sound brings man face to face with a realm far beyond the narrow limits of the human senses. Now, before the molecular nature of matter was known, the sense of smell and, to a lesser degree, that of taste were almost a complete mystery. Knowledge, however, has not lessened the wonder of these so-called chemical senses. It has merely enabled us in some small degree to appreciate their wonder. Now, any substance is composed of invisible particles called molecules. These particles are in continuous movement. In some substances, the movement is so violent that particles near the surface go shooting off into the air. This is what gives a substance an odor. Dramatic proof of this may be had by pouring some mercury into a dish. And then carefully sprinkling the surface of the mercury with a fine powder. Now, if we bring a substance with a strong odor close to the surface of the tub, The powder will be pushed violently away by the invisible particles coming from the substance. A man has devised instruments so sensitive that they can detect 1 part of a substance in 10 million parts of air. Your olfactory organs, however, can detect 1 part in 1,000 million. But compared to that of many animals, man's sense of smell is quite limited. The bloodhound, for instance, has the extraordinary ability to follow a scent when it's hours or even days old. But perhaps the most limited sense of all is the sense of taste. Yes, even the man who prides himself on a very discriminating sense of taste is limited, like the rest of us, to just 4 kinds of taste buds: salt, sweet, sour, and bitter. Did you know that if a person is blindfolded, with his nasal passages completely blocked, he can't tell the difference between an onion, an apple, a pear, or a potato? It's a fact. It's only the odor that makes the flavor different. As we began our study of the mysteries of sense perception, one of the first things we had to recognize is the fact that we do not see with our eyes or hear with our ears. These are merely the external receptors. The real seat of sense perception is in the brain. It is here that we see and hear and detect odors and taste our food and otherwise sense the world around us. And it's a good thing that this is so. For example, if seeing were done only in the eye, everything would be upside down to us. Just as in a camera, the lens of the eye forms the image upside down. The image is then inverted by the brain so that it appears right side up. Now, what would happen if a lens system were used to form the image right side up? Well, the brain would immediately invert the image so that it would be upside down. But would this condition be permanent? To answer this question, we asked Mr. Gratz, our optical expert, to design for us a pair of inverting spectacles. While the spectacles were being constructed in our shop, we faced the problem of who was going to wear the things continuously for several weeks. You'll want to meet our unlucky winner. That's right, me. Even from the first, it was possible to walk in this topsy-turvy fashion, but it didn't take long to develop a rollicking case of seasickness. We decided that for your sake as well as ours, we'd better conduct our first test sitting down. However, just sitting down wasn't so easy. Even the simplest tasks were at first impossible. No amount of concentration or effort could overcome the compulsion to reach in the wrong direction. The inverting spectacles had to be worn every waking moment during the entire period of the experiment. Anytime the glasses were removed, the eyes were closed or fully covered. Walking to work upside down was an exhausting experience, but it provided a valuable period of relearning and reorientation. It also caused quite a stir in the neighborhood. Gradually, it became easier to get around in this upside-down world. By a slow and painful process, the image in the brain had been erected. At this point, we decided to devise a convincing demonstration showing that reorientation had been achieved. The test with the motorcycle went so well that we decided to extend the experiment to flying an airplane, where visual coordination and depth perception are even more critical. The flight lasted more than an hour, during which all normal flight maneuvers were executed. In performing the experiment with the inverting spectacles, we became very much aware of how important it is that seeing is done in the brain, not just in the eye. When you look at a brick wall, for example, staring straight ahead with one eye closed, there is a hole in the picture image sent to your brain. The hole is irregular in shape and occurs 12 degrees to one side. However, try as you will, you won't be able to see the hole. Your mind will fill in the missing detail brick by brick. But why is the blind spot there in the first place? The answer lies in the amazing construction of the eye. The inner curved surface at the rear of the eye, called the retina, is a fantastic thing. Its function is to transform a visual image into electrical impulses which are collected by a network of more than 1 million tiny nerve lines which carry the visual image to the brain. The blind spot occurs at that point in the retina where the nerve lines join the optic nerve. At this point, there are no seeing elements. Now, it's a good thing that this spot is not in the center of the retina, for if it were, our vision would have been seriously impaired. As it is, however, the hole is always there in the image sent to the brain, but the brain always fills in the hole with detail similar to that which surrounds it. But someone says, well, maybe I don't see everything around me. But if what I do see, I see correctly, I'll still trust my senses. Well, recently there's been a great deal of careful research and study into the subject of the accuracy of the senses, and the results have been quite amazing. The scientist, Adelbert Ames, has developed some ingenious experiments. In this figure, the two ends obviously are parallel, but the two sides are not parallel because the two ends are not the same length. This figure we call a trapezoid. Now let's remove the cover. Are you a bit confused? Well, all we've done is cut some holes in the figure and painted it to look like a window frame. But maybe you say, well, you can't fool me, that's still a trapezoid. Well, it's still a trapezoid, all right. But now let's revolve the figure and see what happens. Does the window frame seem to turn, then stop, and reverse directions? Well, such is not the case. It is revolving continuously in a clockwise direction. Now, even when we know this, the illusion still persists, and it looks more like a window all the time. Well, maybe you need a reference point. See if the cube will help you follow the edge of the trapezoid all the way around. Watch closely now. Doesn't help a bit, does it? Not only does the trapezoid still oscillate back and forth, but the cube actually seems to take off and go floating through space. Now, it doesn't, of course. Actually, the cube has been firmly attached to the edge of the figure all the time. Now, an iron bar should make a good solid reference point. Let's see what happens now when we rotate the window. Of course, we know that the revolving window frame cannot possibly bend the iron bar or cause it to cut through the window frame. But this knowledge seems to be of no help at all. The illusion of an oscillating window still continues. From earliest childhood, it has been our experience that windows are rectangles and that all sides are parallel. Your eye sent an accurate image to the brain, the image of a trapezoid painted like a window. But your mind said, ah, that's a window. And rather than give up the idea that all windows are rectangular, your mind accepted all sorts of improbable things. Solid bars bending or cutting through solid matter without even leaving a hole. We emphasize the fact that seeing is done in the mind, not just the eye. And I think you're beginning to see the importance of this emphasis. But Adelbert Ames had some other experiments which were most revealing. Now, as I step into this room, it should be quite obvious that something is wrong, but can you figure out what it is? Your mind may tell you that I have grown smaller. Of course, you know that that really isn't true. Your eyes, however, are telling you the truth. They're telling you that the floor is tilted up, that the ceiling is tilted down, that the walls are badly distorted, that the windows would be almost impossible to make drapes for them. Yes, your eye is telling you all this, but your mind simply refuses to believe it. But maybe this will help. Imagine all of this without benefit of vitamins. But it also works the other way, too. Now, if you'll just step back a bit, you'll see the real cause of the trouble. It's quite obvious at this distance, isn't it? Sloping floor, tilted ceiling, distorted walls. But since you understand this, you shouldn't have a bit of trouble from now on, should you? Or should you? In this house, faces at the window seem to come in assorted sizes, don't they? But there's nothing wrong with the faces. It's those windows and what they're doing to your brain, remember? A small one and a tall one. Let's see if we can even things out a bit. Oh, no, that's even worse. It comes as a distinct shock to most people when they realize how limited and how inaccurate the human senses really are. Now, of course, the scientist is keenly aware of these limitations. In fact, this awareness is the very foundation of modern science. Before the age of science, man had no real concept of an orderly universe governed by unchanging law. He proudly built his theories and philosophies on the meager scraps of information coming from his limited and inaccurate senses. This was a time when alchemists mixed their magic potions, when astrologers tried to predict the future, when phrenologists measured bumps on the head to gauge a man's intelligence. But about 300 years ago, the picture began to change. The age of science was born when man quit trusting his senses and developed instruments to overcome their limitations. Today, man knows that the physical world is governed by universal and unchanging law that has been operating since time began. Man knows that there is rich reward for strict, detailed obedience to physical law, and also a stern penalty for disobedience. He knows that sincerity and good intentions are not enough. Now, this attitude in the scientific realm is relatively new, but it certainly has paid off. As soon as man adopted this attitude, there was a sharp upturn, literally an explosion in scientific progress. And yet, with all the potential for good, this scientific development has brought man face to face with the greatest crisis in human history. Why do we face this crisis today? Well, man has developed an enormous scientific competence almost overnight. But in the spiritual realm, man has all the symptoms of a pre-scientific Dark Age philosophy. He seems to feel that this is a realm composed entirely of intangibles, a realm in which there are no absolute values and no fixed laws. Because man recognizes no law outside himself, he feels free to set his own standards and develop his own set of laws. In other words, once again, man is committed to trusting himself. He feels free to build his own theories and philosophies purely on the meager scraps of information coming from his senses, which in this realm are even more limited and unreliable. How often today we hear someone say, "Well, I have my own religious philosophy." Can you imagine a chemist saying, "I have my own table of atomic weights"? He'd blow his head off in 10 minutes. Such an attitude applied to the physical realm is obviously ridiculous. But is it any less ridiculous when applied to a realm that is far more critically important? Now, if in the physical realm there are absolute values and fixed laws, is it not logical to assume that there is also a master plan in the moral and spiritual realm? And if we dedicate ourselves to obedience to that plan, can we not expect a similar explosive result? But now, the important question. Where can we find these absolute and unchanging moral and spiritual laws? Well, we can find a partial answer in nature. For after all, spiritual laws have a counterpart or parallel in physical law. The law of cause and effect, for example, operates in both realms. History is also a source of information, for the history of mankind is but a record of the inexorable operation of these laws. In the history of nations and in the lives of individuals, we see the result of obedience to God's laws, and also the tragic consequences of disobedience. And then we have this book, the Bible, the Word of God to man. Wherever it has been loved and believed, it has transformed lives and even altered the course of history. But how can we know that this is the law of God? Well, this is a beautiful opportunity to put the scientific method to work. Put these laws to the rigorous test of personal experience in your own life. And what result shall we expect? An explosive change. A change so complete that the words salvation, conversion, and born again will take on a wonderful new and personal meaning.